Bismillahirrahmanirrahim. Here is the course Oxidation Reduction, and today's topic is oxidation of olefinic double bond with iodine silver acetate. So outline of this present session includes oxidation of olefinic double bond using oxidizing agent iodine silver acetate in two different experimental conditions, dry and wet, and we will discuss in each case mechanism of reaction and prediction of the product. So at the end, summary of major points. So we will discuss today olefinic double bond oxidation in terms of its hydroxylation. So these are learning outcomes. Iodine silver acetate, if used as oxidizing agent along with the water in the wet condition, it gives you cis diol, and the process is called cis hydroxylation. It was designed by Woodward, इसलिए हम इसको Woodward cis hydroxylation कहते हैं. तो अल्कीन डबल बॉन्ड, अल्कीन में कोई भी डबल बॉन्ड होगा, आयोडीन और सिल्वर एसीटेट की मौजूदगी में ऑक्सीडाइज होता है इन वेट कंडीशंस में, and you get cis diol. This is the reaction. Double bond, cis double bond, it is in wet condition with silver acetate. It gives you this type of chemical species, which upon basic hydrolysis gives you cis diol, and the process is called cis hydroxylation. Here is the mechanism for cis hydroxylation. Silver acetate in the presence of iodine is converted into silver iodide and iodonium acetate. So this will react with this double bond, and this intermediate is formed called iodonium ion, which is further attacked by acetate ion to give you this type of chemical species. And then neighboring group participation take place. It will attack over here. This leaves the surface. Nucleophilic, intramolecular nucleophilic substitution. And then after the hydrolysis, presence of water, it will attack on this carbon, and this is open. So you will get this type of product, cis diol, after hydrolysis. So again, another presentation of this double bond, cis diol is formed. The mechanism of this reaction involves different steps. The first step is the iodonium ion formation. Second step is the nucleophilic bimolecular nucleophilic substitution reaction. Acetate ion is the nucleophile attacking over here. Iodide is removed. And then this acetate ion, once it gets attached, it will also attached to another carbon. So neighboring group participation take place. And then bimolecular nucleophilic substitution, water will attack over here and this will attack over here. And then this electron density comes here and this comes here. And so you get this type of cis type of product, which upon hydrolysis gives you cis diol. This is specific example. Here is a double bond which get oxidized. This is isolated double bond which gets hydroxylated in the presence of dry. So these are wet conditions. You will get iodonium ion from the back side, and so that is why your product is that in which the two hydroxy group are on the above side. Whereas with osmium tetroxide, you will get this type of product. So if we use this iodine silver acetate or benzoate in dry conditions, this is called prevost reagent, and these dry conditions gives you anti-hydroxylation process, means you get trans diol instead of cis diol. यहाँ पे आप इस डबल बॉन्ड को इसके साथ जब ट्रीट करते हैं और आपके पास दिस इज वेरी बल्की आयोडोनियम आयन के ऊपर, जिसका अटैक बिल्कुल बैक साइड से होगा, जिसकी वजह से आपको ये ट्रांस डायोल मिलेगा. ये है mechanism prevost reaction का silver acetate in the presence of iodine. Sorry, this is benzoate, silver benzoate in the presence of iodine. This intermediate, this is formed, this is prevost reagent. This iodonium ion is inserted across carbon-carbon double bond, and then it will attack over here. This is open, and then neighboring room participation take place here. Here you get this type of intermediate. Then benzoate comes and play its role. It do not attack here, just like water in the previous case. It will attack here from the back side. So that is why we get trans hydroxylated product after hydrolysis. So here is example which also shows cyclohexene. When it is treated with X2, this one is formed. So neighboring group participation take place. So if water is there, it will attack from on this carbon and you get cis hydroxylated product. If water is not there, dry condition, then benzoate acetate will attack from the back side, and here it is open, and you will see your product will be trans after hydrolysis. This is trans diol. Here is a summary. Cyclohexene in dry conditions gives you trans diol. In wet conditions, it gives you cis diol. Here is the mechanism of prevost reaction where lithium bromide is a source of bromine. This bromine is inserted electrophilically. In addition, electrophilic addition take place. We get bromonium ion. Then acetate ion comes, attack over here. This is open. And then neighboring group participation take place. Bromide is removed and we get this type of intermediate. And then what happened? That the benzoate, which is very bulky, will attack from our acetate, will attack from here, backside, and this is opened. So that is why we get trans product instead of cis product. You can compare both processes by comparing their names. Woodward reaction, prevost reaction. Woodward reaction is actually cis hydroxylation, cis diol is formed. Trans diol is formed in case of prevost reaction. Woodward reaction is about the iodine and silver acetate in wet conditions, whereas prevost is the dry conditions with the benzoic acid. So you will see that the final outcome of Woodward hydroxylation is cis isomer, and for trans it is trans isomer for prevost reaction. Here is the example of cyclopentene. With the prevost conditions, dry conditions, you get trans diol. And Woodward reaction of this one, cyclopentene, in wet condition, you will get cis diol. So here is the end of this lecture. We have learned that how silver acetate is acting as oxidizing agent and how it behaves differently in wet and dry conditions, its mechanism and stereochemistry of the product we have discussed today. So this is the end of the lecture.